Hey, what's up, Ziguanas? This is day 11 of the 30 days of Zig Coding Challenge. I invite you one more time to join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language, Zig. My name is Dusan. Welcome to Zignited. So this is actually a second stream today. So I did a few hours ago, I did what I promised yesterday I would do. I did stream live coding of a tic-tac-toe game, and I also spoke about Zig a little bit, like my impression so far in the first 10 days. So if you haven't seen this video, this stream, you can watch it. It's on the playlist. And let's move on to day 11 of coding Zig, and let me open the documentation. And today I was thinking about functions, so I will at least start functions and go from there. Okay, let's first prepare here because this is left from tic-tac-toe game today. I had a lot of fun doing it, but let's move on. So first of all, let's see what they say. Functions are declared like this. They don't say if it can be inside of another function. So in this case, it's not. I will do it first like this, but I will test immediately if I can have, I guess you can have nested functions, why not, but just to see. And this is, I guess, with the input that is I8 and I8 one more, so 2 inputs, and this is, I guess, the output. In this case, they just like test if A equals to 0, they return B, otherwise they return the sum. Okay, so let's go and call this function, and I'll try to print this directly. So here, let's say result equals, come on, type, and then the dot here, and I want to call how it's called add, and let's pass. So if it's 0, it should return B. So let's start with that 0, and then 3, for example. So expect to see 3, right? Yep. And if I send something that's not 0, now it should be the sum 4. Okay. By the way, one more time, I would like to state that this stream series, 30 days of the coding challenge, is about me documenting my learning process, how I learn the new programming language, which I don't have any experience with. I didn't have like 11 days ago now. So it's not a tutorial. I'm not teaching you guys how to code in Zig because I don't know how to code in Zig. So I'm learning it now. But this is the point. And this is the reason why I'm kind of jumping over through some things. So for example, this function is not the simplest one. It has inputs, it has outputs. I could have started with some more basic example, and that's how I do when I teach others who are beginners. But in this case, this is not the point. So I'm just like trying to go as fast as possible through the language itself to learn it. And then once I go through the basics, I will create a beginner's tutorial for Zig. Okay, so then let's move on. What else they have here? The export specifies makes okay, I don't want to export anything now. Extern specifier is used to declare function that will be resolved at link time. Okay, again, a bit more advanced things. I don't want to touch those yet. Fairly cold. Okay, again, I just wanted the basic things. Make it calling convention makes a function not have any function prolog or epilogue. Okay. In the inline calling convention forces function to be inlined at all call sites inline function. So yeah, they are just like jumping through. Pub specifier allows the function to be visible. I was more interested in about like to find out if I can, let's say, have default values for the parameters. Can I omit some of them and things like that? So not these other things that are more advanced, but I don't see an example, so I will try to play myself. Let's see the next one. Pub specifier allows the function to be visible when importing. Again, I'm not going to import anything yet. I'm keeping everything simple in one file so far. Function pointers, So this might be, let's say, one of the basic things that are not something like these other examples where you focus on different things, not on functions themselves. Okay. So maybe I'll try this one. Is there something else? As by value parameters. Okay, this is with functions, function parameter type interference. Okay, inference. Okay, these are more interesting things. So I'll skip over these few things and jump right here. But I haven't touched structs. Okay. Maybe I will jump here. And before I test, they're kind of like mentioning things above and they are explaining it here. The reflection. Okay, these are errors already. Functions, yeah, I jumped over. So let's go back here. And actually the next one. This part, yeah. Okay, so let's actually copy that part. 42 and type of, okay, and then they test it. Okay, let's do that. But I'm not going to run it yet. I want to do something else first. So I can leave it, I don't have to call it. And actually, let me just see if I can define a function first, the thing that I want to do. Let's align the things a bit. Oh, I have two of them now. Delete the outer one. Where 2010 here. Okay, I will come back to that. I first want to do this, that I don't have two same functions. So now let's see here. Then I have function here. Now let's run. Let's see if I'm going to get the same error. Okay, so 2010. So here it's expecting comma. So there is some either problem when you define a function, or there is a different syntax that I'm not aware of. So let's keep that for now. Let's try a different thing. So can I say bi8 equals by default 1? Can I do this? No. So I cannot set default values, at least not in this way. So what if I just do this? No. Okay. Then can I do something like this? No. Okay, so maybe there is a way, but I don't know how. So I'll just keep it as it is. The parameters without default values. And let's see what else I can try. What I wanted to do is, yeah, I wanted to do something else if this worked, but because it doesn't, I cannot play with passing less than one argument here. So that will not work then in this case. Okay. Then I'm very limited what I can check now. Let's then try this part here. The second function, add 42. So the x will be any type. And it will return the type of x. Aha, this is interesting. It's kind of like generic, right? So something like a generic. And then it returns x plus 42. So let's call this one. And see how that will work. I'll keep this commented out. Here I will call add 42. And here I just need one parameter. So let's say 1. It should be 43, right? Now this is not the interesting part. The interesting part is the type of and any type. Okay, what if I pass the float? Let's start first with the one that doesn't have decimal digits. Okay. Then I guess this is going to work. Yeah. What if I try to do very different thing? Will it be coerced to 1 or no? I have to do that manually. What if then I guess I cannot even do something like this, so it will not try to check for sure. This is Python or JavaScript. Oh, actually, okay, it's sending the numerical value. So the character, the Unicode ordinary number, basically. Okay, I remember today from, I'm not typing anything. Today when I played with tic-tac-toe game, I remember this is 9.5 decimal, right? So then 95 plus 42. Let's see if it's going to be what it should be, 137, right? Yeah, it's correct. Okay, this is interesting. Nice. So it takes the numerical value of character. And this can be, so it's basically now it's returning integer because this is treated as a number, as I believe U8. And then it will be U8 as a return in this case. We can actually test that. So I can do this. I can say var. Let's do a const. I will not change it. So let this be equal to, then let's call, I can call for the same value. And then here, okay, I can print the result. And I wanted to call it result. I keep forgetting naming my variables. And here I can keep this, it's okay. But I also wanted to see the result itself. And actually the type, yeah. I wanted to see the type. So type of, I guess it's U8, but just to double check. Oh, it's comtime int. Aha, it treats it as a literal. That is, yeah, okay. Integer literal, so because I haven't defined as U8, so by default this will be comtime integer, like a number. So if I do this, it will be the same. Yeah, and if I do 2.0, it'll be comp time float, right? If I'm not mistaken, I forgot how the type is called. Yeah, comp time float. Okay, okay. Makes sense. Let's see what they did here. They passed one, then they tested if it's comp time integer. Okay, here they specifically said that the type is I64 instead of comp time int. That is by default. So that's why the type here will be the same. Okay, that makes sense. Okay, so these are the very basics of functions. Let's see, inline call, I don't want to touch, reflection, not yet, and then the errors. Yes, so I'll pause with functions, and let me actually do structs because they are using them in the previous examples with functions, and I haven't covered them yet. Where are the structs here? So basically today I will then do more structs, looks like, than functions. Let's see, declare a struct. Zig gives no guarantees about, did they say something before? No. Zig gives no guarantees about the order of fields and the size of the struct, but the fields are guaranteed to be ABI aligned. Okay, so the interface is guaranteed to work, but the order is not guaranteed. Okay. Declare an is for struct. So let's see first what they do here. They create a struct, they call it point, and they define it with these two coordinates basically. And then they create a p, which is of that struct type point. And then I see this now. Luckily, I already know this notation. I was confused. This was very confusing at the beginning, why they put a dot notation in front. I didn't understand it's a struct literal. You can create in this way. Okay, and then they create. This is interesting. They again use the dot notation, so they don't do something like this or this dot x or self dot x. They just say dot x, which is kind of cool because it's minimalistic. You don't need to do. It's understood. So let's do first this part. Then just play. Okay, these are functions. I will leave them. Bother us. Where is it here? Okay, so this is where I intend. This part. Okay. Functions, well, let them be there. I will just not call them. And let's see if this, how this struct looks like if I print it. So if I do a print of this struct, so let's say p equals, and then I'll say how it's called, yeah, p. It's called p. And now this is basically a struct in a struct. So can I actually do, I will try later just to do this. But let's try this. What will happen? Ah. And I forgot to zoom in a bit. Can go larger. Yeah, so this shows the struct without anything here. I didn't have to format. And I got all these. So play dot main dot point. So I guess this is the thread or something. Maybe. Main thread. And then the x is 1.2. So basically this is scientifical. So times 10 to the power of minus 2, which is basically the same. Same here as well. Okay, And what if I did what I want to do, this part? Will this work? No. Unused argument in P, so this is not an error. Aha, okay, yes, yes, yes. I was about to say it's not the error that I was expecting, but it is, because then I saw this unused argument in the formatter, so yeah. Okay, so this is the way it works. Let's see the next thing. Function since the struct's namespace can be called with dot syntax. Okay, cool. So they have struct with 3 fields, and then they define another function inside and another one here, and they test it probably here. So let's copy paste this entire thing and play with it. Let's see first of all how this looks like. So okay, it's vector, I believe 3, probably 3-dimensional vector, then struct xyz, float 32 bits, then they define one function called init. This is kind of like a constructor, right? It receives 3 same types like these fields here. Then it returns the vector struct, okay. And here they directly, just like initialize, they take the parameters and assign to these very... this is... Yeah, I forgot this is directly. So this is basically in this stage here. They're defining things. I was just in a second, my mind went here, and I was like asking myself why I don't see dots. But then, yeah, I remember we are here now. The first step. Okay. The definition itself. The next one. Dot. Okay, that's the name. It receives self vector 3 and the other. So probably it's going to compare them. And it returns the F32, so a number. Let's see what they do. Aha, they multiply the respective coordinates and summarize them. Okay. And they give you the sum of products, right? Okay. Let's see the test they have here. This part. This part I will leave the same. So they expect it to be 0, because they have in every step they have at least 1 0. So here it's in vector 3, here it's in vector vector 3, in vector 2, here it's in vector 1, here it's both actually. And they call it from v1. So let's print this actually. Let's not do error handling yet. So I will say v1 dot v2 equals, and then this, and then here just this part here. What they say, undeclared where's 40? 40 here. The init. So why? It should return. What does it say? Use of undeclared. Aha. I haven't declared it. How come it's declared here? It's the same. 40, 45. Yeah, it is this one. And 48. Again. I literally copy pasted the thing from here. Yeah, I'm not missing anything. Let me double check if I copy pasted in the right way. But this struct starts here, where it ends. See? Then here maybe I have one curly brace less. This is okay, this is okay, and this should be closing this struct. Double check. Yeah. So before the const v1, I'll select everything, do one more time here. Yeah, still the same error. Why? So let's clear things a bit, just be sure. Let's see like this. Why it does not highlight? So yes, this is this one, this is this one. Okay, so this is correct. Then here, this is correct. So this is this one. Why it does not see it? Something is off. But 0, 14, 1, 0, 14, 0. Let's try to define it before. So I don't know why this doesn't work, but let's just try to define it here as a variable. Can it be defined in that way? Yeah, but then I cannot do what they want to do. Yeah, I cannot. It has to be here. So there is a comma here. They are separating things with commas. Yeah, I don't know why their example does not work. These are different examples. So it was cool before because I didn't use the type itself inside of itself. So here vec3, it's used within itself, which should be okay. Let's try to say self instead, if this will work. Undeclared the same thing. Okay, let's just like add, but yeah, it is also here. So I wanted just to remove this init function and then just our code like here without using the init function, but then I remember basically here it's the same problem. So here also it is not visible. Vec 32, vec 3, 32, this. I have no idea. This is like very basic thing that it should work. And it is literally the same like in their example. Aha, maybe it's because maybe it's something like a namespace thing. Maybe I have to define it outside of the main. Let's try that. Yeah, it was that. So I guess it's like the compilation thing. So because this is like in the runtime, running in the runtime, and this has to be declared before. So I didn't pay attention here. They are doing everything outside of the main function. But let's go back to the example. So here, where I okay, this is the output of this part here, right? And then have another print. Where is this one? Ah, true here. Okay. So this is the part. Yeah, because I forgot to do the \n thing here. I always do that. So let's do that here and here. And it will make more sense now. Yes, v2 equals true. So basically, when we multiply, it is equal to 0. It is true that it is equal to 0. So instead of that, I actually want to see this, the result itself. Okay, now let's change this one to 2, for example. So it should be 2 now, right? Yeah, and now let's say here 3, so it should be 5. Okay, and let's do 5 and 5. So 25 plus 5 should be 30. Okay, yeah, 3 times 10 to the power of 1. Okay, makes sense. So I will try to remember this, that I actually cannot refer to the type itself in the runtime. I have to define it here outside of the main. Okay. Next. Okay, this is the word test that I just did. This one is a different Y. Aha, they use it with the struct itself, not with the... I was about to say object because I'm thinking object-oriented. So in object-oriented, this would be a class, and this would be an object, and this would be an object. But here, it's a struct type, so maybe I can say a type here. So they are using this dot method on the type itself rather than on the instance of the struct. Get the same result. Let's see what they say. Probably they're going to say that other than being available to call with dot syntax, struct methods are not special. You can reference them as any other declaration inside the struct. So yeah, they didn't explain what I said, but they went with a different angle. Let's just test this one here. And again, let's actually do this. And this is the operation that I want. And let's say vec3 dot and then 3 dots in this. It should be the same, right? So 30, 3E1. And I forgot to do this. Yeah, same thing. Next example, structs can have declarations, plural. Structs can have 0 fields. Const empty struct. So they declare inside the value of it immediately. Why is this empty? So they don't count this as... okay, yeah. So this is just like the namespace, basically. And inside of that namespace, they create this constant, I. But because it's not with the dot notation, it's actually empty struct. Okay. And then they just print it here. Size. Okay, let's do those two things. Double check. Do something print instead of I expect. So yeah, they still access it with the dot notation, but it doesn't belong to the struct. This is interesting. Okay, let's do that here. And let's do this in the next one. What I say? Okay, my bad. Yeah. Size 0. And the pipe prints nice. Next thing, the empty structs can be instantiated the same as usual. Okay. Let's do this and print it first. I don't need this underscore notation. That's it. How the empty struct looks like when you print it. Probably here I have 20. No. So it's like before, just the name and the empty struct. Okay. We don't need this. It used the variable. Struct field order is determined by the compiler. However, a base pointer, let's close this, can be computed from a field pointer. So if you know the pointer of a field, you can calculate the pointer of a base. Let's do that. Let's see first of all what they do. Set y based on x. X is pointer to f32. Y is f32. Doesn't return anything. Void. Const point. It's a pointer to field parent pointer. First time I see this built-in method. Wait, this is the point that we used before, right? Yeah, this one here. That's the type. Yeah, that's the type. So just, yeah, it's only x and y there. Okay, let's go back to this example. So the function receives two arguments, has two parameters, the pointer and the number. Then they create a constant point, which is a pointer to the struct, which they then calculate by passing this x, which is a pointer of field x. I guess this is specifying the name of the variable, and this is to get to receive the value of it, and then they take the point y. So this is the main function that does the magic under the hood, that does this calculation of the base once you pass in the field. Okay, and then point y equals y. So here, this is the reference. Basically, this is the important thing here, that they say the point is, and then they pass in the value of the x, and they calculate. So this is just like adding the value to y. And let's see what they do to test. They create one point, then they call this, let's copy both of them. Okay, point, did they call it already here? No, this is p, this is point. So they create a point, which is a point struct, which has these values inside in fields. Then they call this, they pass the pointer to x field, to this one, and then 0, 9, which they want to assign here. And then they are expecting, I will just print like always, point.y. That's what they want to see. What happened? Found const 2044. Here, expected expression found const. Maybe it's the same thing like the main. So let's try to do this outside, because I had so far several problems if I try to define a function inside of main. Also defining struct inside of main. The file, okay, now it's different. 83 here. Probably copy paste problem. Point where? 34. 34, where is it? Okay, I also have to define a struct there. This one. Where? 33. Okay, another struct that I should have defined here. Then let's comment out or delete these other. So let's do, just to make it simpler. Yep. What does it say now? Local constant shadows declaration where? 44. Let's wait. 44. here. Shadows declaration of const point point star. Okay, this definition declaration shadows this one. I literally copy pasted. From where? Point. Here is the function point. So here it's a global scope, I believe. Then here let's change it. Just let's say point f from the function. Let's just see if this is going to run without going into details while this breaks. Okay, now it does, and it works as expected. So they expected to see this 0.9. So let me go one more time through this logic. So create a point, which is this struct with these specific values. Then call a function, pass the pointer to the x field of that point, this one, the instance that created here, and the value that I want to assign to y. And then here the magic happens. It creates a point f constant, which is a pointer to the point type of struct, which is getting the value of whatever this built-in function returns when I pass probably the name of the field and the value of the field. So this one will search for this field with this value, and then it will identify the address of the point struct itself, of this actually here. So this is the type, but this is the instance. So then it'll take the address and pass it to this point f. And then at that point here, this is the same like if I were to say point.y equals y. That's why. Okay. Understood. Structs can be returned from functions. Linked list comp time. Okay, this is the example of the linked list, obviously. Let's see what they do. They have comp time type. Okay, these are generics, I guess. I'm not going to touch them yet. I want to play with the basic struct things. Functions called compile time are memorized. Why they now switched to functions in the middle of structs? I mean, I see that they're closely related, but since types are first class values, you can instantiate the type by assigning it to a variable. They use the same linked list. I don't want to do that. Let's see the next one. Default field values. Each struct field may have an expression indicating the default field value. So they can, but I didn't see the examples for the function for default values for the parameters. Okay. Such expressions are executed at comp time. Nice. And allow the field to be omitted in a struct literal expression. And then they provide the example here. So this is the literal, right? They assign it to the A, but not to B. And then let's do actually this. Ooh. Let's do it right before the main. And just for the simplicity, I will delete all these, not to confuse myself. Okay, and then let's see what they do here. Okay, first of all, const full struct. Yeah, this is what I saw in the example there already. Then they create the instance. They call it text. Type is full struct. then they define it here. Oh, I keep forgetting this dot notation here when they want to create a literal, so I will forget these things for sure. Then they set only the b, 5, because this one already has the value. And then I don't need this, I just want to print the x. Okay, makes sense. This was the point here, right? So that it can have the default value. Default field values. Default field values are only appropriate when the data invariance of a struct cannot be violated by omitting that field from an initial initialization. For example, here is an inappropriate use of default struct field initialization. See why. Some threshold struct minimum F32, so they're both F32s. Trying to assign numbers to them. Then they have cons category, which is enum. Not touching this because I don't know how enums work yet. Yeah, so I will do that later. Let's see what they do here. Are they tested? Okay. Above you can see the danger of ignoring this principle. The default field values cause the data invariant to be violated, causing illegal behavior. To fix, remove the default values from all the struct fields. Okay, this is just the fix for the same. And then extern struct. Okay, I don't want to do anything externally yet. Packed struct. Unlike normal structs, packed structs have guaranteed in-memory layout. So they want to say that the normal one don't have guaranteed in-memory layout. Okay, so that means you can have some holes. They are not optimized. Fields remain in the order declared, least to most significant. There is no padding between fields. Okay, Zig supports arbitrary field with integers, and all the normal integers with fewer than 8 bits will still use 1 byte of memory. In packed structs, they use exactly their bit width. Okay, this is similar with Solidity. When I did coding with Solidity, it's similar because you have different size integers and you can pack them in structs. It's a very similar concept. So I also by default they will take more, but if you pack them in structs, you can do the same thing. So luckily this is something familiar. Okay, bool fields use exactly 1 bit. Nice. Maybe in memory. And enum field uses exactly the bit width of the integer's tag type. Okay. A packed union. So in enum, like I said, I'm just going to ignore for now. Next time maybe I'll do it tomorrow. Packed union field uses exactly the bit width of the union field. Okay, this is again union. I haven't touched them yet as well. So just like struct part is interesting to me. This means packed struct can predict a bit cast, pointer cast to reinterpret memory. This even works at comp time. Let's see. This is a huge example. Let's see what they want to do. Full pack struct. Okay, number U16 divided. They use this pack struct, and they have these smaller bit sizes. So then what they do, try do the test. What is the test? Here it is. Comp time do the test. So they try to do it first in runtime, then in the comp time. Let's see what the test is. Expect size of full, and this is the full extra. Okay, so here they use 16, and here they have 3 pieces that add up to 16. Okay, so the size in bytes is 2. I guess this is going to be true and true without running it. Then let's equals full equals number, full number equals, what is a number here? Yeah, field full number. So they are setting the value 1, 2, 3, 4, and this is 2 bytes, and this is also 2, 1, 2. Okay, once divided equals bitcast full, and then they taking basically this one and bitcast it. So I guess from this what I see, they're just like taking the bits and casting them in this order, if I'm not mistaken, so that the first byte will come here from here, and the second will be divided into these two pieces. Then they test if the half one is 3, 4, which is basically the least significant. How it's, I confused them because it was long time when I learned. So I think this one is called least significant bit, right? The right side. So then this is the byte, the first byte from the right, let's say like that. And then the third quarter is this one, right? Yeah, 2. And then the next one is this one. Okay, nice. Unordered. Okay, this is the array of size 2 of uints 8. And they do the bitcast full again. What else they said they want to do? Pointer cast. Pointer cast. Okay. So they cast it in this case to an array, I believe. Switch native Indian, Endian. Dot big. Okay, I'm not going to do this because I didn't do switches. So I will understand probably how they work, but I just don't want to skip over things. That's the reason. Let's see what else. Backing integers in third. Fields total. Okay. Explicitly provided in force at compile time. Const s equals spec struct utility 2 in b8. Then they say 4 and 2 values. A is the backing. It's inferred from fields total bit with backing. So let's go to the next one. It allows the address to be taken off 1 byte aligned fields. Okay, so these are more, I mean, they're all interesting things, but there's so many of them, and I'm already like streaming for 1 hour, and this doesn't end. And I already streamed today like 1 hour and a half and more. So I think for the day, or today, this is more than enough. So then let me think about the plan for tomorrow. So have more things to do with slices still. Not slices, structs, I wanted to say. But maybe it would be, maybe I'll come back to functions. I remember they used structs, and I didn't want to play with them before I go through the basics of structs. Let me see. Yeah, they have a lot of these. Okay, this is the struct part, right? Yeah. One example. This one I remember. Yeah, so there aren't many pieces left with structs. So maybe I'll just do that one function example. Maybe then I will do enums. They are the next in line that I cover them because they were mentioned a few times with some other things that I went through. So then I have enums for tomorrow. So let's say I will just finish, not finish functions, but I will do this part where this one example where they use struct with function, and then I will move on to the enum. Sounds like a plan. Okay. That would be everything for today. Thank you guys and see you tomorrow. Bye bye.